formulas of each 6. We didn't touch on the tan yesterday. We just touched on the sine and the cos. The tan we would use if we just said tan. Right? If it said tan 165, then I would do tan 120 plus 45. It would be the same thing. The formula is just different. Okay. But you just have to do that. If I did cotan, I would just find tan and then flip my answer. Correct? Okay. We have to be able to spot these. So if I ever get a sine, cos, sine, and they have the same angles, they might give me, what I did yesterday is I gave you the left-hand side of the equation and made you find the right-hand side, correct? But what they can do is they can give us the right-hand side and make us find the left as well. So if I go here, I have sine 48, we'll treat that as x. Cos 17, we'll treat that as y. Cos 48, well, 48 was x, so it's going to stay x. And sine 17, so it's going to stay y. So technically, I'm using the formula sine x cos y minus cos x sine y. What formula does that work with? Which formula does that go with? Cos or sine? X plus y, x minus y. Which one does it match with? Sine, cos? Which one? So sine and then x minus y, right? So this is actually the formula that matches with sine x minus y. We agree? Off our formula sheet, it's the same formula. Now, all we need to do is fill in the x's and y's. So this equals sine, and what was x? 48 degrees. Minus what was y? 17 degrees. So what did we get an answer of? Sine of 31. And that's what they're going to look for as a multiple choice answer. There's also the double angle identities in here, but you guys have looked at those a lot already, the double angle ones. So remember your double angle identities are 2 sine x cos squared x minus sine squared x, 2 cos squared x, a minus 1, and 1 minus 2 sine squared a. So they can give you this side and ask you to work your way back to the left. Okay? So this one, I can look at this and say, okay, cos squared, this is x. Sine squared, this is x, because they're the same, correct? So this is the same as saying cos squared x minus sine squared x. Does that match any formula on the formula sheet? Which one? Cos 2x. This is just the formula for cos 2x. We agree? So then this cos squared pi over 3 minus sine squared pi over 3 equals cos 2. But instead of x, I'm going to put pi over 3. This is just 2 over 1 times pi over 3. So it's just cos 2 pi over 3. And if they wanted to, we could actually get an answer for that, because cos 2 pi over 3 is negative a half. But I didn't ask for that. It just says write as a single trig function. You guys are going to try C and D. See if you can write them as a single trig function. A couple trig functions here, and write it as like cos or sine or whatever. All right. This one would match with cos x, cos y plus sine x, because it matches 88 with the x, and sine y, which is actually the same as cos x minus y. So we're going to get cos, our x is 88, minus our y, which is 35. And what do we get? Cos 53. This one we have 2 sine pi over 2, cos pi over 2. So we're going to get 2 sine x cos x, which is the same as sine 2x. So we're going to get sine 2 over 1 times pi over 12, which equals sine pi over 6. This one I just want you to simplify it as one of the primary trig ratios. Go. You're simplifying this as a primary trig ratio, which means sine, cos, or tan. So If you want to simplify it, simplify whenever you read simplify, you write the question out or whatever the heck they gave you, and it's equals simplify, equals simplify, equals simplify. That's what simplify is. Left hand equal signs running down the side because you're just simplifying and you're showing every simplified version of that. So, it doesn't say solve. Solve means x equals something or theta equals something. Simplify means make it look simpler. That's it. So here we have 1 minus cos 2x over sine 2x. Now cos 2x, I think honestly you have two options. There's three, but if you do cos squared x and sine squared x, we're getting a little excessive, right? So there's two. Now, in my mind, I look at this and I say, this is how it helps me out sometimes with cos, is I have a 1 and I want the 1 to go away. So I need to pick the one of the coses that if I distribute it in here, I'll get a -1 and they'll cancel off. You could also do it by trial and error. But I'm going to pick the 2 cos squared x minus 1. And the reason why, no, that's a lie. That would make it minus and minus plus. I'm going to pick the 1 minus 2 sine squared x because then it will cancel. Because I'm putting it in for this whole thing. And remember when I told you when there's a minus sign in front, that minus sign has to distribute to the entire bracket of what the heck you're substituting in. Correct? So I'm going to sub in 1 minus 2 sine squared x. And then on the bottom, sine 2x only has one option, 2 sine x cos x. Now, like I said, I'm telling you why I picked it. I picked it because if I go 1 minus 1, they're going to cancel off, correct? So my number is going to go away. But I have to remember to distribute the minus sign into here, so I'm actually going to get plus 2 sine squared x. Do you think that on the diploma they'll leave the answer where you forget to distribute the minus in and leave it as a negative sign? Yep, they absolutely will. The option gets picked more than the correct one. It's just a sad day. So you have to distribute that in and it comes a positive. And then we have 2 sine x cos x. Now sine squared x, 2 sine squared x is positive, does nothing because this would be 0 plus 2 sine squared x. Do I have to write the 0? Do I have to write 0 plus 2 sine squared x? No, I can just write 2 sine squared x, and if I want, I can write 2 sine x sine x. Could I not? Is 2 sine squared x just a sine x times a sine x? Just two of them. You could leave it as a squared. There's nothing wrong with that. I'm just showing you that it's the same thing. Over 2 sine x cos x. These cancel, and I'm left with tan. So sometimes this is how they ask the question. They'll say, this simplifies to what? A, B, C, or D, right? And then tan x would be one of the options, and you would pick it. Okay, then we're going to flip over. Back to the page we were on yesterday. We did these ones yesterday. We're going to go down to here to tan 105. It's going to say determine the exact value of tan 105, which means I have to use my unit circle. However, 105 is not on my unit circle. What of its best friends is on my unit circle? Anyone know what we could use? We could use 60 and 45. We could do 135 minus 130. There's a whole bunch of options we could use, correct? If I have the option of using things from the first quadrant, I will, because then they're both all just positives. So I'm going to choose to use 45 plus 60, but you could totally do 135 minus 30, which is where my head went to first, and then I was like, quadrant 1, you can use quadrant 1. You'll still get the same answers, okay? But then it would have just been a subtraction formula. So here we have, I'm going to use tan 30, that's a lie, tan 45 plus 60. And it doesn't matter what order you use them in when it's an addition. Now the tan formula is that pretty. It's a lot of fractiony thing. So tan A plus B is tan A plus tan B. Over 1 minus tan A tan B. So I'm going to put 45s in for the A's, and I'm going to put 60s in for the B's. And that'll get me 0.5 right off the bat, right? So it's going to equal tan 45 degrees plus tan of 60 degrees over 1 minus tan 45 tan 60. And the reason why I like quadrant 1 is I have them memorized. Tan 45 is 1, tan 60 is root 3, tan 30 is root 3 over 3. Like my head has them memorized. If you don't have them memorized, what do you have to do? Sine divided by cos. So y divided by x, and then rationalize that and use it. Okay? But I know tan 45 is 1, and I know tan of 60 is root 3. And if I can use tan 60, that is the one I'm going to use every single time. Any 60-degree tan will always get me root 3s. Any 30-degree tans get me root 3 over 3s, which are fractions with radicals. If I can stay away from fractions with radicals, I stay away from fractions with radicals. Okay? So here I'm going to get 1 plus root 3 all over 1 minus 1 times root 3. 1 times root 3 is just root 3. So I'm going to get 1 minus root 3. Now some people say, I'm done. Nope, you won't be done. They'll never have that. You have to rationalize your denominator. I have a binomial denominator, so I have to multiply by the what? The conjugate. Good thing you popped in time. So we're going to multiply by 1 plus root 3 on the numerator and denominator, and I'm going to have to FOIL to distribute my binomial and binomial. So I get 1 times 1, which is 1. 1 times root 3, which is 1 root 3. Then 1 times root 3, which is 1 root 3. And then root 3 times root 3 is just 3. All over 1 times 1 is 1. Plus root 3, 1 root 3. Minus 1 root 3, which means they cancel, which is the point of using a conjugate. And then minus root 3 times root 3 is minus 3. So I'm going to get root 3, 1 root 3 plus 1 root 3 is 2 root 3s. 1 plus 3 is 4. Over 1 minus 3 is negative 2. And then this is like the quadratic formula. Whenever you have a fraction and you want to reduce the fraction or take something out, it has to come out of every term or no terms. It has to come out of the triangle, yeah. So I can take out a 2, but better yet, I'm going to take out a negative 2 because I want this denominator to go away. So 2 divided by negative 2 is negative 1. 4 divided by negative 2 is negative 2. Negative 2 divided by negative 2 is 1. So I'm going to get negative 1 root 3. Do I need the 1 in front? No. Minus 2 all over 1. Do I need a 1 if it's in the denominator? No. What if the whole numerator cancels off? Do I need a 1? The whole numerator cancels off? Yes. Because if that's the case, you would say 1/4 equals 4, which it doesn't, right? So if I have 1 in my numerator, I need to keep it. But 4 over 1 does equal 4. So if I have 1 in my denominator, I don't, right? 1 in my numerator, I have to keep. 1 in my denominator, don't have to write it because every number is over 1. So that would be the answer. Now remember, I can check every single one of these. So you can go in degree mode, and you can type in tan 105. And then you can type in minus root 3 minus 2, and they should match. Should be the same decimals, correct? Every single one of these I can check. There's just no amount of math enter buttons that's going to turn that into negative root 3 minus 2. Because some people think they're just going to use their calculators. There's no buttons that turn that into that. They equal the same. So, you have a little bit of homework for tonight for the Battle of Alberta. So write these down. It's page 306. Just so you know, on Friday I'm walking around and checking the homework this time with my physical eyeballs, because people's homework checks are getting abysmal. With my eyeballs. Real eyeballs. Okay. So page 306, number 2 and 4. 2 and 4 like we did at the very beginning. And then 8b.